Greetings and welcome once again to my new calculus channel. My name is John Gabriel and today I'm going to be talking about one of the oldest mathematicians. He wasn't Pythagoras, it was actually Thales, but he is one of the oldest mathematicians, and Pythagoras got most of his knowledge from Thales, as they say it in Greek. So Pythagoras was not a mystic, by the way, as for example you'll see idiots like this guy over here, in his short, claiming that Pythagoras was not a mathematician but a mystic. He was actually a mathematician. There was no mystique about his theory of numbers. The only thing that happened was that his knowledge was lost. Okay, it was lost for thousands of years until somebody rediscovered that knowledge. You're looking at the person who rediscovered the knowledge that Pythagoras had, and if he did write it down, well, there's no record of it. Okay, so I'm about to show you right now that the actual theorem of Pythagoras isn't a big deal at all. It's what Pythagoras knew about the concept of number that matters. Okay, not the garbage of that little triangle with a square on it. I'll show you that's not even important in any sense of whichever way you choose to think about it. And I'll show you a couple of other things. So sit back, relax, and enjoy the rest of the video. Let's begin. Now why can't I close that? Now I can. All right. So what about Pythagoras? Now, the theorem of Pythagoras, first of all, is it's not about the square on the hypotenuse. Okay, that's basically just one of the versions. what the theorem of Pythagoras really says, is that if you take a similar planar form on the hypotenuse and on the sides of a right angled triangle, as you see in front of you, the sum of the areas on the sides will equal to the sum of the area on the hypotenuse. What I've done here is I've just taken a triangle here with a height 5, and of course I've adjusted the heights here so that they're in proportion to the sides on these triangles. And of course 4 plus 1 is 5. Okay, but it doesn't just work with squares and triangles, it works with any similar shape. Okay, let's look at some of the similar shapes. So if you take a semicircle, it will also work with a semicircle. In other words, if you add this blue area to the green area, you'll get the red area. It will work with a pentagon or a hexagon or anything else. If you take this blue area and add it to the green, you'll get that area. It will work with any other similar shape. Okay, I'll give you a link to this article and you can try it on your own. Okay, so it takes genius to discover these things. Now, you might say to yourself, well, wow, that idiot Andrew Wiles, who won close to €1 million, spent time proving that there is no integer greater than 2 that suits us. Well, it wasn't about anything but area. So the fact that no integer greater than 2 exists is no surprise at all. Okay, and he was on a fool's errand to find an integer greater than 2. This theorem applies only to planar surfaces which are similar on the hypotenuse and the sides of a triangle. Okay, so you can draw a shape like this and just make sure that the sides, if you choose to make a triangle on this side, make sure that the sides are in proportion on this little triangle and the big, and this triangle on this side, or whatever shape you choose on any of the sides. This theorem will always work. It relates the sum of these two areas to this area here. Okay, so Andrew Wiles was an idiot. Okay, why was he an idiot? Why? Let's see why. Okay, well, because this here relates area. Okay, so for example, here, what would you write as an equation here? Would you write uh, area of triangle, area of, it's hard to write with my mouse, area of triangle on hypotenuse equals to area of triangle on the sum of the areas on the sides, right? So this, let's call this area 1 and area 2. So it's equal to A1 plus A2. So how would you write that? I mean, are you going to write hypotenuse, half hypotenuse times this height, etc., etc.? You can't write this as, for example, whatever the lengths of these sides are, 2 2 squared plus 4 squared equals to whatever this thing here is, the length of this here, squared, okay? I mean, you can write it in this way, but you can't write it as integers. So the idiot, the knucklehead, and I have to call him that because that's what he is, Andrew Wiles, spent all that time proving something that was totally unremarkable, totally useless, totally worthless, had no basis to be proved. Well, of course, it was posited by another idiot, that idiot Fermat, the French idiot Fermat. So, okay, so now what I've shown you here is that, without belaboring the point, that Pythagoras, the great Pythagoras, by the way, was not about that. So, what was he about? Well, he was about numbers. So, in my article called Gabriel Arithmetic Without Numbers, I show you how georithmetic was what Pythagoras used, and arithmetic is what happened when Pythagoras tried to use numbers instead of line segments. Okay, let me repeat that. Georithmetic happens without numbers, and you'll see all that in my article called Gabriel Arithmetic Without Numbers. But arithmetic happens with numbers. Okay, and Pythagoras knew about arithmetic. So, and of course, he knew about ratios that have no measure. So if you say, well, if you read about, read from stupid people who've written articles about Pythagoras, that he was overwhelmed and shocked when he discovered that the diagonal of a square didn't have a measure. He wasn't shocked at all. He knew very well that it didn't have a measure, and he could prove that it didn't have a measure. So a lot of this mystique nonsense that you hear, which came along centuries later, is just basically a load of rubbish. He wasn't a mystique, okay? And there's no actual quote that number is everything. There was nothing written down even to that effect, that Pythagoras thought that number describes everything, okay? Number is very important, but algebra is less precise than geometry. And of course, Pythagoras knew my georithmetic. So how could he have thought that numbers were everything? Because he could perform ratio arithmetic, as I show you in this article, Gabriel Arithmetic Without Numbers. And if you haven't read this, you can't understand number. You can't understand fractions. You can't understand the operations of arithmetic. You have to read this, because I published this information over 2,500 years later. It took my genius to reveal this to the rotten human race who has rejected me. Okay? I should be winning the Abel Prize, not that fucking moron Andrew Wiles. If you're not already a subscriber to my channel, become a subscriber to my YouTube channel. Follow me on academia.edu and click like. And if you want to learn more, join my members only channel for $4.99 a month. Till next time.